In this video, we're going to take a look at another tool that can be used to solve non-right triangles, known as the law of cosines. We've previously discussed how to use the law of sines to solve non-right triangles. To use the law of sines, we need to know one of the angles of the triangle and the side length of the opposite side from that angle. For example, in this picture, we would need to know angle A as well as side length A in order to use the law of sines. However, here are two examples of triangles in which the law of sines will not help us in any way. The first example, we do have one angle that is known, in this case the 40-degree angle, but we do not know the side opposite that angle. This side over here is unknown. We do know, though, the other two sides of the triangle, the two that are adjacent to the 40-degree angle, but the law of sines would not help us in this situation. Likewise, in the second example here, we don't know any of the angles of the triangle and instead know all three of the side lengths. And so here we would also not be able to apply the law of sines because we don't know any of the three angles and therefore cannot find the sine of any of those angles. So in order to solve triangles like the two shown here in red, we need to use another tool, and this is where the law of cosines will come in. The standard version of the law of cosines is stated here. Notice there's actually three different formulas, one solved for a squared, one solved for b squared, and one solved for c squared, so that regardless of the situation we find ourselves in, we can always find side length A, B, or C using one of these three formulas. Notice, however, that they are virtually the same. For each of them, we have a side length squared on one side of the equation, and on the other side of the equation will be the sum of the squares of the remaining two side lengths minus 2 times the product of those remaining two side lengths multiplied by the cosine of the angle opposite the original side. All three of these formulas are best used to solve for the side length in a triangle because each of them is solved for a side length squared. And so computing the value on the right-hand side of each of these equations, we can take a square root of that value to obtain the actual side length for our triangle. These formulas can be used to find angle measures, which are unknown. However, it is often easiest if one solves these equations first for the cosine of the angle that's at the end of the expression on the right-hand side, in terms of all of the side lengths, and then use that formula in order to compute the angle. To do that, we just take one of our laws here. For example, I might take our first one that's solved for a squared, and we're just going to simply solve this for cosine of a. So what we would do first is we would subtract b squared and c squared to the other side. So we would have a squared minus b squared minus c squared would equal negative 2bc cosine of a. We're now going to divide both sides by negative 2bc, which is the coefficient there in front of cosine of a. And we see that the negative 2bc's cancel, and now we just have a cosine of a on the right-hand side. But in order to not have a negative in our formula, what we're going to do is we're going to change the sign of all of our terms, essentially multiplying by -1 over -1. And when we do this, we get b squared plus c squared minus a squared all over 2bc, and that's going to equal cosine of a. And this formula is now solved for cosine of a, and on the other side of our equation, we have the three side lengths, a, b, and c. And so if we know the three side lengths of our triangle, we can use this formula to find the cosine of angle A, and therefore use the inverse trig function, the inverse cosine, in order to find the value of A. We could also solve the second and third versions of the law of cosines above for cosine of B and cosine of C, respectively, using the same exact procedure. And here are these three formulas, all solved for cosine A, cosine B, and cosine C. Notice that all three of these formulas can be computed using only side lengths A, B, and C. And since these are solved for the cosine of our angles, we can easily use the inverse cosine function to use these formulas to find the actual angle measure for any of these angles. So to see an example using the law of cosines, let's consider a triangle with angle B equal to 50 degrees, side length A equal to 4, and side length C equal to 6. And here we're asked to find the side length of B. Since we want to find a side length, we want to use one of the first three versions of the law of cosines. And since we want to find B, we're going to use the one that is solved for B squared. And the rest of that formula is A squared plus C squared minus 2AC cosine of B. Notice here that all of the unknowns on the right-hand side of this formula are given to us: side length A, side length C, and angle B. So we proceed just by substituting all of our values in. So we're going to have 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 50 degrees. And we can just go through and do the arithmetic here. We know this is going to be 16 plus 36 minus 48 cosine of 50 degrees. And of course, 16 plus 36 will be 52. So we have 52 minus 48 cosine 50 degrees. At this point, there's nothing else that we can do without a calculator. So we use a calculator to compute the number 52 minus 48 cosine of 50 degrees. And we obtain 21.1462. And that's an approximate value rounded to 4 decimal places. And then to find the side length B, we're going to take the square root of this number, 21.1462. And that is going to be approximately equal to 4.5985. And so our value of B in this particular triangle is approximately 4.5985. For another example, let's consider a triangle with side lengths A equal 3, B equal 5, and C equals 7. And we'd like to find angle B. In this case, since we want to find an angle, we're going to use one of the second set of versions of the law of cosines, and in particular the one that is solved for the cosine of angle B, since that is the angle that we want to compute. The rest of that formula is A squared plus C squared minus B squared, all over 2 times A times C. Notice that all of the side lengths here are given, and we can easily fill in the formula on the right-hand side of this equation. We have A squared, which is 3 squared, plus 7 squared, minus 5 squared. Notice the order of those side lengths does matter. The side length opposite the angle we're looking for, in this case side length B, is the one that is subtracted. And in the denominator we have 2 times A, which is 3, times C, which is 7. And so we just go through to compute these quantities. So we get that cosine of B is going to be 9 plus 49 minus 25, all over 42, which is 2 times 3 times 7. And 9 plus 49 is going to be 58. When we subtract 25 from that, we're going to get 33. And so here we see that cosine of B is equal to 33 over 42. And so in order to find angle B, we're going to use the inverse cosine function, or the arc cosine function. And B will end up being the inverse cosine of 33 over 42, which is approximately 38.21 degrees. And so using the law of cosines here, we see that the angle B in this triangle would be about 38.21 degrees.